Good day, students. This is the clip on circles. So I assume you've already written down the learning objective for the day. So let's go right into the notes. Title this notes on circles. Alright, write this down. First thing we're going to go into is the vertex form of a circle. So vertex form. The vertex form of a circle is given by x minus h squared plus, notice this is a plus, y minus k squared equals r squared. Okay? These are letters I coded in blue, color coded in blue, have special significance in the equation of the circle. Okay? The number next to the x and the y form the center. So the center is hk. Number next to the x is the x coordinate. Number next to the y is the y coordinate. hk, just like that. And the radius is given by the square root of the last term, which is r squared. Okay? Make sure these two quantities are in parentheses by themselves with no coefficients. And then the number, the last number on the other side of the equation will be your square of the radius. So when you square root the last number, you get the radius right there. Alright? Okay, now let's see if we can apply this to an example to determine the center and the radius of a circle. Example 1. Write this down. Example 1. Find the radius and center. Then graph. Okay, so we're going to be doing some graphing here. It's advisable that you have a graph paper so your circles will be more accurate. Alright, let's say the equation is x squared plus y plus 3 squared equals 25. Alright, so let's find the center here. In order to find the center, we need to have this written in vertex form. So there has to be a number next to the x in the parentheses and a number next to the y. We see that the y is already written in that form, but we need a number for the x. So there is no number being subtracted from the x, right? So what number is no number? What number do you subtract from x that gives you x? The additive identity of x is 0, right? So x minus 0 quantity squared plus y plus 3 quantity squared equals 25. Alright? Now, with this in mind, we can determine what our center and radius is. So, our center, you do the opposite, it's opposite of 0 is 0, 0 has no orientation, and negative 3. Opposite of positive 3 is negative 3. And then your radius, you get your radius by taking the square root of the last number. Make sure you have no numbers in front of these two parentheses when computing the root here. 5. What does 5 being the radius mean? 5 being the radius means that from the center, 0, negative 3, you're going to be going all directions, 5 units. So you're going to go 5 units to the north, 5 units to the south, 5 units to the east, 5 units to the west. Okay? You're going to be going in all directions that way. That's what 5 being the radius means. Alright? Alright, let's graph this. Let's generate the graph of this circle. All we need is just a center and the radius, okay? So let's make our coordinate system. X-axis is in the 0, so our y-axis goes right to the center. Our y-axis is negative, so our x-axis has to shift the opposite direction. Since it's negative, our y-axis has to go up a little bit. Okay, so it can go negative. Alright, so draw a coordinate system. Label them y and x. So we're going to go 0. There's no move to the left or right. And then we're going to go down 1, 2, 3. And that gives us our center. Okay? So let's graph it. We're going to go 5 units up, 5 units down, 5 units to the left, 5 units to the east. Okay, so let's graph it. 1, 2, 3, 4, 5. Step. Right there. 5 units up. 1, 2, 3, 4, 5. 5 units down, sorry, from the center. 1, 2, 3, 4, 5. 5 units to the right. 1, 2, 3, 4. 1, 2, 3, 4, 5. 5 units to the right. Okay? This should be a perfect circle. Try your best to make a nice circle as best as you can. So I'm just going to try to curve this like this. This is just a sketch, so if yours isn't perfect, that's fine. And then like that. Alright? So when you after doing a circle, I just want you to indicate the radius. This right here, this segment from here to here, is your radius. Alright? So that's how you do it. Now let's consider another example. What if we had a situation like this? Example 2. Same process. What if we had x plus 3 quantity squared plus y minus 1 quantity squared equals 50. Okay? So first thing we want to do is find the center, and then we also have to find the radius after that. Okay? Alright, write this down. Now let's find the center. We need to take the opposite of the number next to x for the x coordinate, and the opposite of the number next to y for the y coordinate. So opposite of positive 3 is negative 3. Opposite of negative 1 is positive 1. Boom. There goes your center. Radius is determined by taking the square root of the number to your right. Square root of 50. Now 50 is not a perfect square, so we need to use a calculator here to find a decimal approximation of what 50 is. So if I take the square root of 50, let's see, square root of 50, my eyes are not working. Okay, 7.0 or 7.1, so slightly over 7, right? So square root of 50 is approximately 7.1. What does that mean? It means I'm going to go 7.1 units to the north, south, east, and west. That's what the radius means. You go in all directions, 7.1 units, but this is just a slight indication. You need to go all directions, 7.1, okay? To be more precise, like there, all directions, 7.1. But I'm just going to do north, south, east, and west. That's good enough, okay? For the purposes of this example. So let's go ahead and draw this graph. How do I draw my axis? The x is negative, so my y has to shift the opposite direction. So since x is negative, y has to shift to the right, to the positive side. And since y is positive, x has to shift to the opposite direction, which is downwards. Okay? So you always have to go backwards. For the arrows, label your axis, x and y. Now let's graph it. Negative 3, 1, 2, 3. Boom. Like that. It's negative 3. And your x-axis is 1. Like that. Okay? Now, there goes your center. So we're going to go 7.1 units in all directions. So we're going to go 1, 2, 3, 4, 5, 6, 7. and then a little bit extra. 1, 2, 3, 4, 5, 6, 7, and a little bit extra. 1, 2, 3, 4, 5, 6, 7, and a little bit extra. And then 1, 2, 3, 4, 5, 6, 7, and a little bit extra. Alright, so that gives you your circle. Connect the dots as best as you can. You're going to have a bigger circle. Something like that. Then connect it. Oh, that looks good. I'm getting better at this. Alright, then connect the circle. Like that. That's a very circle I've done ever. Anyway, so there goes your circle, okay? And then draw your radius. Okay? From the center to the circumference, that is your radius. Okay? Alright? Radius. Radius. Alright. So that's that. That was your one. Alright, so we're going to work on the first set of practical problems, and then we're going to start lifting the heavier weights. Alright, welcome back. Now, I'm going to look at the second part of the notes. So write down these title notes too. Place in equations in vertex form. So we're going to use the completing the square algorithm to place the equation of circles in vertex form, and then we will graph the resulting equation by using the methods I just showed you. So let's go ahead and do that. So what we're going to do first is consider the following example. Example 3. Place the given equation. Write this down. Place the given equation in vertex form. Find the radius. Find the center and radius in graph. Find the center and radius. Then graph. Alright, let's consider this one. What if we had the problem x squared plus y squared minus 4x plus 6y minus 3 equals 0. Okay, we'll write that down. Now to do this, we need to collect like terms, put like terms close to each other, and toss the foreign body to the other side, okay? So what do I mean by like terms? X and 4x are like terms because they contain a similar variable x, even though they have it to different degrees. We're going to have x squared minus 4x close to each other, plus, now y squared is going to go close to 6y plus 6y. 3 has neither an x nor y, so it needs to be tossed to the other side. So you add 3 to both sides. That will help you get rid of that foreign body right there with no variable next to it. So equals 3. Okay? Now, having in this form, what we're going to do is we're going to go ahead and partition our variables in front of the sign like this. This creates two worlds. It creates the x world and the y world. What we're going to be doing is completing the square in the x world and the y world simultaneously. And whatever foreign term we introduce, we'll place it here so that we can preserve equality on both sides of the equation. Okay, so complete the world in the complete the square in the x world and the y world. So to complete the square in the x world and the y world, we need to do b over 2 squared. So to complete the square, you need b over 2 squared, yes? So we have two b's. This is a in the x world and b in the x world. This is a in the y world and this is b in the y world. Okay? So let's watch this carefully. B in the x world is -4, because that's right there, the coefficient of the first degree variable x. b in the y world is 6, because that's the coefficient of the first degree variable y. So what do you do here? You divide by 2, and then you square it, as this suggests, b over 2 squared. So you divide this by 2, which is negative 2, and then you square it, which gives you 4. Same thing in the y world. Divide by 2, 3 squared, 9. These are the two numbers that complete the square in both worlds. Okay? So we're going to add them in. We're going to have x squared minus 4x. Insert this term that completes the square in the x world. Plus y squared plus 6y. Insert this number that completes the square in the y world, plus 9. Equals 3. Let's see. I added 4 and 9 to the right side. So I better add it here so that I don't change the problem, yes? So you add 4, because of that 4 there. And then add 3. Oh, sorry, add 9, because of this 9 here. Alright, now I'm going to apply that factoring trick we've done before, which is to factor a perfect square trinomial. You read the first and the last and bring down the middle sign. Okay, read the first and the last, bring down the middle sign. Do it on both sides. Okay, so the factored form of the x world is going to be x minus 2 quantity squared. Okay, and then the y world plus y plus 3 quantity squared. And then if you add all this together, 3 plus 4 plus 9, you get 16. Okay, so this is the vertex form. So let's identify this is vertex form. Now let's find the center, radius, and graph. So the center here is going to be opposite of negative 2, 2, opposite of 3, negative 3. And then the radius is going to be what you get when you take the square root of the last term, which is 16, and that's 4. 4 down means you're going to go 4 up, 4 down, 4 to the right, 4 to the left, all directions. Okay? So that's how you do it. Alright, let's graph this. Now to graph this resulting equation, let's place our coordinate system down. 2 is positive on the x, so our y-axis is going to go down a little bit. And then y is positive, and y is negative, so our x-axis has to shoot the opposite direction, which is to the right a little bit. Alright, so let's graph our center. Center is 2, 1, 2, and negative 3. 1, 2, 3. So we're going to go 4 in all directions. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Alright, and then you connect the dots. Try to make a circle as best as you can. 3. Please do not draw a rhombus or a rhombus. A rhombus from. Ooh, this is terrible. Okay, that wasn't me. It was this electronic device. Alright, so there you have it. There goes your circle, and then indicate the radius. Pardon this crooked, so the circle here. This is radius right here. Okay? So that's how you do it. You notice if you look at this problem, we're just adding a layer of complexity, which is double completion of the square. That's what makes it a little bit more complicated. Alright? So there you have it. Alright, let's try another example, and then we can do the second part of the password. Write this down, example 2. Now we're going to try the problem 2x squared plus 2y squared minus 4x plus 12y minus 33 equals 0. Alright, so what we're going to do first here is place like variables close to each other and toss the formula over to the other side. Okay, so we have 2x squared and the 4x. They both have x's of different degrees, bring them next to each other. And then on the y, we have plus 2y squared plus 12y next to each other. 33 has no x or y, foreign, so it needs to be tossed to the other side, so use the opposite. Plus 33. Okay? So this becomes equals 33. Now we're going to partition the worlds down in front of the sign, right here. That is how you partition your worlds. Okay? Alright, and then now we need to make sure that there are no variables in front of the squares so we can root the squares with ease. So all we need to do is we need to factor out this 2 from the x square and this 2 from the y square also. So factor out the 2. Factoring out the 2 basically means that you're dividing by 2, right? So you factor out 2 from this term means you're dividing that by 2, and you factor out 2 from here, it's like you're dividing it by 2. So you're left with x squared minus 2x plus. Same story here, factor out the 2 so that you have y squared standing alone. So divide that by 2, divide that by 2, and then you're going to have y plus y squared plus 6y equals 33. Alright? Now we're going to make perfect square trinomials here and here by completing the square. To do that, we need b over 2 squared. So for the x world, b for the x world is the coefficient of x right here, which is 2. And b for the y world is the coefficient of y right here, which is 6. So you divide them by 2 and then you square them, right? Square half of both of them. So b over 2, 2 over 2 for the x world is 1. When you square 1, you get 1. That one I'll put over here in a minute. For the y world, divide that by 2, which is 3. When you square it, you get 9. That I'll insert in here. Okay? So we're going to have 2 times x squared minus 2x plus 1. That's the number that completes the square in the x world. And then in the y world, you have 2 times y squared plus 6y plus 9. That number completes the square in the y world. Equals 33. Okay. In order to preserve equality, whenever I add it on this side, I have to add on this side. Notice we have something in the parentheses and a number outside that should be distributed to it. So in the x world, I added 1 inside the parentheses, but what did I actually add to the x world? I actually added 2 times 1. What is 2 times 1? 2. So on this side, for the x world, I'll add 2, because it's 2 times 1. On the y world, what did I add? I added 9 in the parentheses, but there's a 2 here. So what did I actually add to the y world? I added 2 times 9, which is what? 18. So plus 18. Okay? Keep that in mind, because this is where people make mistakes. They put 1 here and 9 here instead of 2 and 18. You have to distribute before you add it here. Alright? So let's factor this. You read the first and the last, bring down the middle sign. You're going to have 2 times the quantity x minus 1 squared for the x world plus, bring down the 2. Same business here. Read the first and the last. So 2 times quantity y plus 3 squared. And then here you're going to have 53. 53. Right? Now, you may not have a square. You may not have a 2 in front of the parentheses, so divide everything by 2, because you can have a number in front of the parentheses for the vertex form. So divide this by 2, divide this by 2, and divide that by 2. So that gives us x minus 1 quantity squared plus y plus 3 quantity squared equals 2 goes here 2, 2 goes in 13, 6, 26.5. Alright? Alright, so let's find our center radius. Center. Center, you do the opposite of the x. What is the opposite of negative 1? 1 opposite of the y, opposite of positive 3, negative 3. That goes your center. And then the radius. The radius is basically the square root of 26.5, which is approximately what? Let's compute the square root of 26.5. 26.5 square root, 5.1. 5.1. Let's just use 5.1, okay? 5.1. So 5.1 in all directions, up, down, right, left. So there you go. Okay? Now let's go ahead and draw the graph. The x is positive, so you move your y-axis to the left a little bit. Y is negative, so you move your x-axis up the opposite direction a little bit. So let's draw a center. Our center is going to be 1 and -3. 1, 2, 3. So there goes the center. So you're going to go 5.1 in all directions. So you're going to go 1, 2, 3, 4, 5. And then some. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then 1, 2, 3, 4, 5. Like that. Connect the dots, and that's that. This. Like that. Like that. Alright. And then you indicate your center on your radius. Right? And then there goes your radius, right there. Okay? So that's how you do it. Alright, so you're going to work on the second part of the classwork right now.